Hi there, this is your favorite math learning channel, and I have an equation problem for you. So we are supposed to find integer solutions of this equation, and they're just natural numbers, so they're positive. Well, if you can just factor both sides in an equation, it would be awesome. But if you can just factor one, it may still be helpful. So if I just factor this left side, it will be x minus y. X squared plus xy plus y squared. So this is equal to that, xy plus 61. Okay, cool. So here I can make a little observation. Here, if I look at x and y values, so since they're both positive, this thing is also positive, because x is positive, y is positive, 61 is positive. So x cubed minus y cubed is actually also positive. So here, but I can also find that x has to be greater than y, and they're also both positive. So this is something I find, not it's given in the question. But now I can use this. Since x minus y is just greater than 0, it's actually, I can say that it's greater or equal than 1, because they are both integers. And why is this useful? Because now I can say that this thing, so if this is greater or equal than 1, this thing has to be lesser or equal than this thing. Why did I do that? Because now if I can have an equality like this, I will just have these two simplified, and I will be able to find bounds for x and y. So for example, here I would have x squared plus y squared plus xy lesser or equal than xy plus 61. Now I can just cancel these, and I will get that x squared plus y squared is lesser or equal than 61. Well, this is really useful because it lowers down my options quite much, and then I can just work with some cases. And here again I could use this, because if this thing wasn't greater or equal than 1, for example, it could be 1/2, and then I wouldn't be able to say this because it would be bigger. So it works like this. I can just say this thing is less or equal than the right hand side. And now what can I do is, well, this limits my options pretty much. For example, if I put x is 5, is 25. If I put 6 for x, and so it's 36, plus 25 is exactly 61. So I know that 6 and 5 is, like, even if this is a solution, this is the biggest pair I can get. So here I can say that just 6 greater or equal than x greater than y. So y can be just 5. So I can just say 5 greater or equal than y bigger than 0. Okay. Well, actually this thing doesn't need to be true. Okay, so I can just keep it like this, y, and so yeah, it's enough for me. X is just bigger than y, bigger than 0, so y cannot be 6. Okay. And now, so I have just 5 values of y, which is from 1 to 5, and I will write them, and I will also teach you a trick how you can actually just examine these cases. So y goes from 1 to up to 5. If you put y is equal to 1 at the original equation, you will get that x cubed minus 1, so it will be minus x minus 61. So it will just give you x cubed minus x minus 62 is equal to 0. If you put 2, it will be x cubed minus 2x, and this will be just 8, so it will be minus 69 equals to 0. So I will just go like this. I actually won't do that. The last term is just going to be minus 5x. It will be 125 plus 61. It will be minus 186 equal to 0. So I basically have 5 equations, and I'm trying to find, so since these are just integers, it's what I wanted. I want to find integer solutions of these cubic expressions. And how can I do that is where my trick comes from. There is a way that shows us if there is a solution of any polynomial and rational roots follow they have a form. Okay, so for example, if I have an equation, if I have a polynomial an x to the n, an minus 1 x to the n minus 1, it can be any degree up to a0, and I know that if there is a solution x which is in the form of p over q, so I mean that rational solutions of this equation, not all roots have to be rational, but some of them may be rational, and this thing follows the rule that p divides, so this top part divides the last constant and q divides the first constant an. So this is really useful, and it's actually easy to prove that, and we are going to use this trick. So I will just show this is not true, like I will just use this trick to show that y1 is not true, and we will then just skip some of them and we will just proceed to the answer. For example, if I check that if there is there a rational solutions of this equation, well, also I know that just checking rational solutions is enough for me, because I'm just looking for integer solutions, and I will get rational. It's even too much for me, but I can work with that. So I know that, so this constant is just 1, and if I look at the rational solutions of this, so I will say that if there is a solution, it will be in the form of x is equal to p over q, and so q will divide 1, so q has to be plus or minus 1, and p p is just gonna be dividing 62. P divides 62, so p can be, so this is 2 times 31, so either p divides 2, or I mean I can just say p is equal to 2 plus minus 2, or plus minus 31. So basically I can have just plus minus 2 over 1 and plus minus 31 over 1. So basically I just have only 4 candidates for rational solutions of this equation, and you can just check all of them. For example, you can put 2 minus 2, well, it's too low to reach to 62, so they don't satisfy, and I'm not gonna do it for 31, but it also doesn't satisfy. You can check that. Also, we would see that even if this is a solution, 31 is too big, because we said that at most x can be 6, so there's no solution for this, and there's no solution for any of these except for when y is equal to 5. You can check these cases. It's just same for all, and now let's check it for all. So I'm saying that for the last one, so I'm saying that the solution is in the form of p over q. So q has to divide the first constant, which is just 1. So q is again just 1. It can be minus 1 too, but I will just put the minus for the p. It doesn't matter. So now I will just factor this 186. So I will see what's its divisors. So 186 is gonna be equal to, so it's just 93 times 2. So this is 31 times 3 times 2. We again got 31. Perfect. So so it's just 93 times 2. Well, this actually gives us only 8 values of 186, so it only gives us 8 values, but there are also negative ones, so there's in total 16 values for it. But we can try only the little ones and see if we are lucky. So from here I can say that p divides these numbers, so it can be, for example, plus minus 2, plus minus 3, plus minus 6, plus minus 62, any combination of these. Okay, well, I will only check these ones. I don't need more. So for example, if like it can be plus minus 2, plus minus 3 over 1, so it's just over 1. I will not write that, over 6. So it goes like this. There are a few more values, but if we just find one, and we will be lucky, and we will get a solution. So for example, if you put 2 is again just too small to reach to 186. It won't work. Negatives even won't work. it won't work. Even less. So here basically, since x cubed and x has the same value, has the same like sign, it's also helping us. If I put 3, it will again not help me. -3 is again won't help. If I try -6, it could actually work. If I put -6, oh no, if I put -6, this thing just gets really low. But if I put 6, I will get 216 minus 30 minus 186, which is equal to 0. So x is equal to 6 actually in a solution. And we also knew that 6 is the biggest number we could get. I also didn't need to check other ones because I wrote the lowest ones, so p can be just 1. I also had option 1 for this. I didn't write that. There is also option plus minus 1. Okay, so p could be like this ones or just something bigger, but I knew that x is less or equal than 6, so the biggest could be 6, and I tried it and it satisfies. So x is actually a solution. And from here I knew that there is no solution y 1, 2, 3, 4, and there is only a solution for 6. And I also found that if x is 5, if x is 6, y is 5. So there is only one pair satisfying this equation. So our solution for xy is equal to 6 and 5. And this is our answer.